Okay, I'm just playing. You may have mistaken it for an external hard drive or maybe a Thunderbolt dock, but no. This is actually a powerful PC, given the size, of course. Now, most small form factor PCs are sized to be built around a CPU cooler, but Streetcom said, screw it. Let's just make the entire case the cooler. That's right, this is a completely fanless case at this size. Question is, did the fancy engineering that they had to put into this puny, passive powerhouse make it a complete nightmare to work with? We've got our heat pipes, and we're going to find out.
NZXT wants to make building a custom PC easier, and with NZXT Build, you just set a budget, see how the computer performs in your favorite games, and Build takes care of the rest. Use the link below to get your own custom PC today.
The Streetcom DB1 Max looks exactly like its sister case, the explicitly non-Max DB1. But there's one big difference. The Max variant uses not one, but both sides of the chassis as heatsinks for the CPU. Or really, APU, as there's no standalone graphics card here, nor space for one. That increases the total heat dissipation of the fanless design from 45 watts up to 65. But it creates an interesting problem. Getting heat from the APU to the left panel / heatsink is a straightforward enough endeavor. A couple of these U-shaped heat pipes, a bunch of thermal compound, and another heatsink to spread the load, but how do you do that for a heatsink that's located on the opposite side of the case? You know, around the back of the motherboard. Well, that's where some clever engineering comes in. These U-shaped heat pipes bend around to the back of the motherboard and contact the right side plates as well. Now, before we get to what is surely the most finicky cooler install ever, there are some concessions that need to be made to get a fanless PC under 6 liters of volume that promises some serious gaming chops, and it starts with the motherboard. ASRock's X300 TM ITX. This isn't a run-of-the-mill ITX board, no. This is thin mini ITX. It's the same footprint as ITX, but adds a 2.5 centimeter I/O shield height restriction. If you stare at it long enough, you can start to see how the design differs. There's no fitting desktop RAM in this thing, so SODIMM, laptop memory sticks, are used instead. We have a couple of these here. And where is the usual ATX power input? There isn't one. This board is powered from 12 volt via a little 4-pin up here, or with a quick jumper swap like so, you can feed it 19 volts via a barrel plug on an external power supply, like we'll be doing here. We have this boy here. What makes this build actually work is the small wonder that is AMD's Ryzen 7 5700G APU. The rated TDP for this thing is 65 watts, which is actually precisely what this case is rated for too. Even though TDP isn't really a useful number these days, as chips can boost for as long as they want, as long as there's headroom. It flaunts 8 cores and 16 threads that can boost up to 4.6 gigahertz, and there's 8 cores of Radeon GPU baked inside that should give us ample gaming performance. But we'll see to that once we get this whole shebang together. Let's go over what we have here. So we've already talked about the CPU. This is the motherboard itself. We went over it a little bit, but let's take a look at the more typical components of it. Right here, we've got 3 USB 3.2 Gen 1 Type A ports and a Gen 1 Type C port. We've got audio in and out. It's pretty standard. It's nothing special. A serial port, which is kind of interesting. I appreciate it, but you know, it's whatever. We've got 2 HDMI 2.0 ports, but only one of these is going to be accessible because one of them's on the other side. Check that out. I don't think I've seen that before. That's thin mini ITX for you. I think I would have given up that serial port for 2 HDMIs, but that's just me. Let's see, 2 SODIMM ports. These are going to be used for our crucial DDR4 3200 kit. These are about as fast as we can reasonably expect out of SODIMMs, I think. I took a quick look around and I couldn't find anything faster. Unfortunately, that's just kind of what you had to live with on a low profile system like this, but you also get 2 M.2 slots. One is a 2230 for your Wi-Fi or a very small form factor M.2 SSD, and you got a full-size M.2 SSD port up here as well. The SSD we're going to be popping in here is a Crucial P5. We're just going to be using Collins bench drive to speed things up. You probably want to have something a little bit bigger and or faster, depending on what your use case is. I think this is just a 512 gig. This is all you get. And yeah, that's all the components. Like, it's not going to be a very complicated build, or at least not as far as component density goes. That, I guess, leads us to the fun bit. It's time to put it all together. Installing the CPU is pretty easy, but you're going to want to pay attention to the little golden triangle here to tell you where to put it, because this is a very weird orientation for this socket. But if you orient it just right, it should slip right on down there, and you're good to go. Now the RAM is a little different than you might be used to. I'm not sure how many of you might have installed SODIMM before, but basically you got to get it in underneath these clips because they're in the way. There we go. Aligned up with the notch, slide it in, then push it down until you hear a click. SSD is the same as any other SSD you might install on an M.2 socket. Now you just align the SSD with this notch here, and then screw in the screw. You don't want it too tight, you just want it to hold down. These screws are very easy to shear off if you tighten them too much.
Okay, and that's it for the build.
Yeah, that's it. Build's done. You know, we could run the system like this, actually. It wouldn't run very well. It might shut off, but, you know, we could do it.
Let's get in the case.
I mean, I was kind of hoping we didn't have to do that, but that's what the video's about, so...
Yeah.
Okay, let's get it in the case. What am I looking at here? This obviously is going to mate somehow. This is what looks like the motherboard tray. Well, clearly I need to read the instructions at this point, so give me one moment. Okay, so I need to install the cooler first, which I think is in this box here. That looks for all the world like a water block almost, except no, it's not. The heat pipes slide into this thing. So it's not like putting anything in here like water or air or anything. The heat pipes just kind of live here. The lengths to which people will go for a small PC, am I right? Am I supposed to be using thermal compound for this?
Yes.
Oh, this is gonna be miserable.
Yes.
Just came back from vacation and this is what I'm doing. All right, let's get some thermal compound on that CPU and get this copper shim on it. Apparently that's what we need to do. That's not a lot of thermal compound in one of these. It's enough for the CPU though, but I already got some on my fingers because of this application method. So I'm wasting a whole bunch of it. Do we have, oh man, I've got it all over me. Already, this is just one packet. I need so many of these. This here shim just goes on like that, I guess. It just lives there.
So how much do you think this case costs?
I want to say $300.
That's way high.
Hi.
Would you believe me if I said it was $125 US?
Really? No, I wouldn't, because you're getting the cooler and you're getting the case, and it's like all these different parts. I mean, it's miserable to build, but like that's less than I thought it would be. Oh, I got thermal compound everywhere now.
But it's part of the adventure.
We're gonna be here a while.
Yep.
Please, better instructions. If you're gonna save money on assembly costs, the least you could do is, you know, make it very clear what goes where. And there's your cooler, presumably. Oh God, how am I supposed to?
Do you need assistance?
This is, ah!
Are you having fun yet, Anthony?
I'm having a blast. Wait, how am I supposed to?
I think you should only go till the screw protrudes through the nut.
Whatever I do, it needs to be even-ish. Oh God, the board is bending. Like real bad, actually.
How bad? Oh.
I'm like, oh, okay, so we got these spring screws, so they'll stop, you know? They'll stop when they need to. No. Instructions unclear, motherboard taco. You're having a lot of fun, aren't you, man? This is my favorite build ever. I feel like I'm not making any progress on this build. Just like, everything I do is like, just a drop in the bucket, you know?
I'd say you're a solid, like, 65% of the way to turning it on.
Well, you didn't have to crush my spirits like that.
Would it help if I said that you're more like 69% of the way there?
Nice. It's done. I hope I actually put that jumper to 19 volts. Let's give it a shot. Yeah, it's heating up, 36, 37. Is it actually gonna boot though? It booted. It booted! Isn't it amazing that we needed a thermal camera just to know whether the computer was on or not? That's pretty great. Like you press the button and literally nothing happens. Okay, T-die is 48, 47. Okay, it's going down. Let's hit it with, what should we hit it with? It doesn't like that. But the CPU temperatures still seem pretty good. The motherboard says that it's at 115 degrees. I don't believe that for a second. That's a false reading. GPU temperature says that it's at 38.
That looks like 10 FPS.
It is 7, but of course this is like 4K. I could probably stress it a little harder if I went with a lower resolution. This is mostly stressing the memory at the moment. Let's hit it with Prime 95. Let's just burn it. GPU temperature is at 58. CPU temperature is currently at 61. Yeah, now it's thermal throttling. What's going on? So the motherboard is currently thermal throttling us pretty hard. Look at that. All that work, and here we are getting thermal throttled. Obviously, people aren't going to be running Prime 95 all day, but this is a little disappointing considering that the chassis itself is fully capable. Like, this is not even hitting anywhere close to a high temperature. It's in the 60s. The chassis is more than capable of taking this amount of heat, and yet we're thermal throttled based on the motherboard. The VRMs are just burning up. We went and grabbed an 80mm Noctua fan to kind of point into the case and see if that makes a difference, and sure enough, it does. So you can see the exact moment that we put the fan on it. It's like kind of like stopped thermal throttling.
Why is the motherboard at over 100 degrees?
Because the VRMs have no cooler. That's what the problem is. The VRMs don't even have a passive heatsink. So they're not getting any cooling whatsoever. There's no airflow inside the case. The only reason we're getting anything out of this is because we're putting air over the VRMs.
But the thing that gets me is that Streacom sent this board.
They sent this specific board?
Yes.
Like, it's possible that there's an issue with the sensor.
Possible that talk going it could have done something.
That is possible.
Yeah.
I'm not above saying that I broke it. Do you want to, like, contact Streacom and be like, hey, have you guys seen this happening?
I can do that.
All right, here's the situation. The ASRock X300 TM ITX motherboard we installed, this guy right here, gave us some weird performance under synthetic loads. The board was throttling far before the case was even being pushed close to its limit, so we pulled it all apart, slapped a Noctua U12S onto it, and lo and behold, yep, those VRMs are toasty. Over 130 degrees. Our goal is to test the case here, and with it throttling this way, we were unable to do so. To rectify that, we called our friends at ASUS and snagged, well, one of these, an ASUS Pro H410T, and equipped it with an Intel Core i5-10400. It's spec'd to the same TDP, 65 watts, and it doesn't cook the VRMs nearly as much as the ASRock board. Let's give it a go in Blender. So starting off, CPU temperature is going up to about 70. We'll see how high they go though, because this is entirely passive, remember, so there's nothing to kick in. And once it hits the thermal soak, it's just going to keep getting hotter until it throttles. That's the idea anyway. We're at 100 degrees on all the cores now, and it is in fact thermal throttling. It's getting kind of toasty now. It actually does feel warmer on this side than this side though. That's interesting. All right, let's see how toasty this thing is actually getting. So on this side that I said was a little bit cooler, it's about 39, maybe 40 degrees in the hot spot there. Yeah, roughly 40 degrees. If we move around to the other side, yeah, like 43 degrees. How about that? I was right. What are we looking at right now? Looks like we've dropped down to 3.6 gigahertz, still at 100 degrees Celsius. What's the power draw right now? 57. So it's not looking good for the 65 watt claims that Streacom made here. We are looking at a 43 degree hotspot back here. So it's risen by 3 degrees at least since the last time I looked at it. Oh wow, the heat. I can feel the heat coming up off of it. It's pretty amazing actually. And like, here's my hand. I don't know if I can, yeah, you can kind of see it. It's kind of glowing off my hand on the bottom there. It's such a cool concept, you know? It's just there needs to be a little bit more efficiency in the thermal conduct, like the contacts, you know? Like, you've got heat pipes you're putting in with thermal compound. Like, that's not gonna be as good as a soldered heat pipe into a aluminum block. And unfortunately, that seems to be what we're seeing here. Like, obviously this is heating up and it's transferring heat pretty well, but not well enough. We went from 65 watts at peak, I think, to 53, 52 watts towards the end of the run there. And now we're sitting at 4 watts idle. So unfortunately, I mean, it worked. You could run it this way, but I wouldn't recommend it. It's 100 degrees. The downside to running the CPU like this is that it's an Intel CPU with an Intel iGPU, and the gaming performance is frankly crap compared to the Ryzen 7 5700G. We saw about 55 FPS in Rocket League at 1080p with everything turned to performance settings. If ASRock pushes a BIOS to fix the issue on this motherboard, then that would be perfect. AMD's iGPU performance makes for a much better gaming experience, but you know, given that there are no other AM4 thin ITX boards out there, and we don't even know if a BIOS update can fix this issue, we're hooped. So, where does that leave us? We're a bit disappointed that the AMD setup throttles so badly, but it does game well in a normal use case. And a build like this isn't meant to be a render farm. If we were to temper our expectations around running full bore, then sure, this is a cool little case, but honestly, the limited options for thin ITX, compounded by the difficult assembly, makes this build not something I can suggest.
Thanks to FreshBooks for sponsoring this video. Now, I'm gonna go ahead and guess that you are not an accountant, which is why you're gonna love this software. It's built for freelancers and small business owners who don't have time to waste on invoicing, accounting, and payment processing. In fact, FreshBooks users can save up to 11 hours a week by streamlining and automating pesky admin tasks like time tracking, following up on invoices, and expense tracking with features like their new digital bills and receipt scanner. Over 24 million people have used FreshBooks and love it for its intuitive dashboard and reports because it's easy to see at a glance where your business stands and even easier to turn everything over to your accountant come tax season. 94% of FreshBooks users say it is super easy to get set up and running, and with award-winning customer support, you are never alone. So don't wait, try FreshBooks for free for 30 days, no credit card required by going to freshbooks.com/Linus. That's freshbooks.com/Linus.
Thanks for watching, guys. This thing isn't so amazing, but if you want to check out something else that's a little bit on the weirder side, maybe check out the video we did on the Streetcom DA2 back in the Ultimate Compact PC video we did in 2019. It's a lot more fun, I assure you.